Welcome to our deep dive into building effective agents with large language models. Our sources focus on insights from Anthropic, a leading AI company, specifically their December 2024 document titled Building Effective Agents. This document is a goldmine of practical advice on maximizing the use of LLMs for complex tasks. We'll be exploring how to get the most out of these powerful tools.
It's interesting how Anthropic distinguishes between workflows and agents. Workflows are like following a strict recipe with predefined steps. Agents, on the other hand, are more dynamic and adaptable, like chefs who can improvise based on the available ingredients.
So, agents have a degree of flexibility that workflows lack, which is important when deciding which approach to use. Anthropic suggests starting simple and adding complexity only when necessary. Why is that?
They highlight that optimizing individual calls to the LLM, perhaps by providing relevant information or examples, can be incredibly effective. Think of it as giving the LLM the right tools and context to do its job well.
Makes sense. So when would we move beyond individual calls?
Workflows are a natural next step when you need predictability and consistency, like automating a specific business process. Imagine a factory line, each step precisely defined and executed in order.
But what if you need more than just a factory line?
When you need true flexibility and decision-making at scale, that's when agents really shine. They can adapt to changing circumstances and make judgments on the fly, like a seasoned chess player responding to their opponent's moves.
It seems that Anthropic emphasizes building the right system, not necessarily the most complex one. Let's delve into the foundation of these systems. The augmented LLM. What exactly makes an LLM augmented?
Think of it as an LLM with superpowers. It's enhanced with capabilities like retrieval, tools, and memory.
So it's like giving an LLM access to a vast library, a toolbox, and a photographic memory.
Exactly. Retrieval allows it to access external data, like finding a customer's purchase history from a database. Tools empower it to interact with the world, perhaps sending an email or performing a calculation. And memory allows it to retain information, learning, and evolving over time.
Anthropic emphasizes tailoring these augmentations to specific use cases. They also suggest exploring their model context protocol, acting as a universal translator to integrate third-party tools seamlessly. It sounds like they're trying to make these powerful tools as accessible as possible.
Moving on from the augmented LLM, let's explore some common workflows Anthropic outlines. We'll start with prompt chaining, which involves breaking a task into sequential steps, with each LLM call processing the output of the previous one.
It sounds like a relay race where each runner or LLM call passes the baton, building on the progress made.
A classic example is generating marketing copy and then having a separate LLM automatically translate it into multiple languages. Or using one LLM to create a document outline, another to check it against specific criteria, and a final one to generate the full document based on the approved outline.
This chaining approach seems effective for tasks easily divided into subtasks. Anthropic also discusses routing. What's that about?
Routing is like a triage system, directing incoming information to the appropriate destination. Imagine a customer service system where inquiries are routed to specialized departments based on their nature, each equipped with relevant prompts, data, and tools.
This streamlining allows for more efficient and accurate responses. Anthropic then introduces parallelization, leveraging the power of multiple LLMs working together. How does that work?
Parallelization has two main forms: sectioning and voting. Sectioning divides a task into independent parts that are run concurrently. Imagine one LLM processing user queries while another screens them for inappropriate content.
So it's like having a team of specialized LLMs, each handling a specific aspect of a task simultaneously. What about voting?
Voting involves running the same task multiple times with different LLMs and then combining their outputs. It's like assembling a panel of experts to weigh in on a complex issue.
So you would use that when you need multiple perspectives or want to increase confidence in the results, like having multiple LLMs analyze code for vulnerabilities and then combining their findings for a more comprehensive assessment.
Exactly. Now let's move on to the orchestrator worker workflow, which takes a hierarchical approach to task management.
This sounds interesting. Tell me more about how it functions.
In this setup, a central LLM acts as an orchestrator, delegating smaller tasks to worker LLMs. These workers, each with specialized skills, complete their assigned tasks, and the orchestrator synthesizes the results to produce the final output.
So the orchestrator LLM dynamically assigns tasks to its team based on the project's evolving needs, like in a coding project where the necessary steps depend on the initial code analysis.
Precisely. Then there's the evaluator-optimizer workflow, a continuous cycle of improvement.
How does that one work?
Here, one LLM generates a response, and another acts as an evaluator providing feedback. This feedback loop refines the output, much like an editor working with a writer.
It's a constant process of generation and refinement. For example, in literary translation, the translator LLM generates an initial translation, while the evaluator LLM critiques it, suggesting nuances and improvements.
Now, let's talk about autonomous agents, representing a more advanced stage of agentic systems.
I'm intrigued. Tell me more.
Autonomous agents operate independently, making choices based on environmental feedback and continuously adapting, taking LLM decision-making to a whole new level.
That implies a high degree of trust in the LMO's decision-making. What real-world applications can they handle?
Anthropic highlights their success with a coding agent that resolves real GitHub issues based solely on pull request descriptions. They also have a computer use reference implementation where their LLM, Claude, can use a computer to perform tasks like web searches or scheduling appointments.
These examples show the potential for automating complex and dynamic processes, but Anthropic emphasizes the importance of thorough testing and appropriate guardrails. It seems they are advocating for a cautious approach, given the autonomous nature of these agents.
They stress that building successful LLM-based systems isn't about creating the most complex system, but about choosing the right system for the specific need. Simplicity, transparency, and carefully crafted agent-computer interfaces are key principles they advocate.
Before we move on to specific examples and delve deeper into crafting effective agents, is there anything else that stands out to you from this initial exploration?
One thing that struck me is Anthropic's emphasis on the agent-computer interface. They suggest investing as much effort in designing this interface as one would in creating user-friendly interfaces for humans.
That's a fascinating point, highlighting the importance of how these increasingly capable agents interact with the digital world.
It reminds us that as we build more sophisticated agents, we need to ensure they can effectively and responsibly navigate the digital world. This raises questions about agent-computer interaction, which we'll explore as we continue our deep dive into building effective agents. Anthropic provides valuable insights into real-world applications of these workflows. Take, for instance, a coding agent designed for the SW Bench verified benchmark. This agent works solely from a pull request description, much like a programmer receiving instructions for a new feature.
So it analyzes the request and then creates a solution, similar to a human developer. Can you explain how this agent interacts with its environment?
This agent interacts with a simulated computer environment, mimicking the tools a real programmer would use. It navigates the file system, reads and modifies code, compiles, runs tests, and ultimately generates a solution. It utilizes a loop of LLM calls to plan, execute, and evaluate its actions.
This feedback loop seems vital for the agent's learning and adaptation. It's constantly assessing its progress and adjusting based on the results.
This continuous evaluation and refinement is key to its effectiveness, allowing the agent to dynamically adjust its approach based on the feedback from the simulated environment. Anthropic emphasizes that this agent, while capable, is designed with simplicity in mind.
Why is simplicity so important when designing agents for complex tasks?
Simplicity makes the agent easier to understand, debug, and maintain. Complex agents with convoluted logic and dependencies can become unwieldy and error-prone. It's about creating a robust, reliable, and manageable system.
Like a well-organized machine with clear, understandable parts, this emphasis on clarity extends to their focus on transparency in agent design. What does transparency mean in this context?
Transparency means making the agent's reasoning and decision-making processes visible, like providing a detailed log of its actions and the rationale behind each choice. This visibility is crucial for building trust in the agent's capabilities and understanding how it arrives at its solutions.
This transparency allows us to see not just what the agent is doing, but why, helping us identify potential biases, errors, or unintended consequences. Anthropic also stresses the importance of carefully crafting the agent-computer interface, or ACI. Why is this interface so critical in agent design?
The ACI determines how the agent interacts with the tools and resources available in its environment. Anthropic suggests investing as much care in designing the ACI as one would in creating user-friendly interfaces for humans.
So it's about creating an environment where the agent can focus on the task without being hindered by a clunky or confusing interface.
A well-designed ACI reduces cognitive load on the agent and minimizes the potential for errors. Anthropic cautions against over-reliance on frameworks for building agents. While these frameworks can be helpful, they can also introduce unnecessary complexity.
So it's a trade-off between ease of use and understanding. Frameworks can streamline development but might obscure the underlying mechanisms.
Anthropic recommends starting with basic LLM APIs directly and only using frameworks when they provide a clear advantage. It's about understanding the fundamental building blocks and avoiding unnecessary abstraction.
This approach aligns with their philosophy of starting simple, understanding core principles, and building upon them thoughtfully. Now that we've explored the workflows and design considerations for effective agents, let's examine two specific use cases where Anthropic highlights their value: customer support and coding.
Customer support is a natural fit for open-ended agents. These interactions often involve a conversational flow where the agent needs to access external information, understand customer intent, and take action to resolve issues.
It's like having a virtual customer service representative capable of handling a wide range of inquiries and requests.
Agents can leverage tools to retrieve customer data, access knowledge bases, and even execute tasks like issuing refunds or updating tickets. They can navigate the conversational flow, understand customer intent, and provide accurate and helpful responses.
This seamless integration of information and action seems crucial for a positive customer experience.
Anthropic also highlights the importance of clear success criteria and feedback loops in customer support applications. Metrics like customer satisfaction, resolution rates, and first contact resolution provide valuable feedback for evaluating agent performance and identifying areas for improvement.
It's about continuously monitoring and refining the agent's performance to ensure it meets its goals and delivers high-quality service.
Some companies are already using agents for customer support, charging based on successful resolutions. This demonstrates growing confidence in the capabilities of agents to handle customer interactions effectively. It's a testament to their potential to streamline processes, reduce costs, and improve customer satisfaction.
Now let's move on to the second use case: coding. Anthropic sees this domain as particularly well-suited for agents. Why is that?
Coding offers a well-defined problem space with clear success criteria and objective measures of output quality. This makes it an ideal environment for testing and refining agent capabilities.
It's a domain where the results are readily quantifiable, providing clear feedback for the agent to learn and improve.
Agents can be trained on vast data sets of code, learning coding patterns, conventions, and best practices. They can even generate novel code solutions, demonstrating creativity and problem-solving ability.
Anthropic mentions their coding agent, which we discussed earlier, as an example of how agents can tackle real-world coding challenges.
This agent, which can solve real GitHub issues based on pull request descriptions, uses a combination of code analysis, code generation, and automated testing to find solutions. It's a powerful example of how agents can automate complex coding tasks and assist human developers.
This raises the question of whether these coding agents will eventually replace human developers.
Anthropic emphasizes that while automated testing can verify code functionality, human review remains crucial for ensuring solutions align with broader system requirements and design principles. It's not about replacing human developers, but about augmenting their capabilities, freeing them from tedious tasks and allowing them to focus on higher-level design and innovation.
These use cases, customer support and coding, highlight the potential for agents to transform various industries.
They demonstrate the versatility of agents and their ability to tackle both conversational and task-oriented challenges. It's important to remember that each use case has unique requirements and constraints that need careful consideration during design and deployment. Anthropic's insights into these use cases provide a valuable starting point for exploring the potential of agents in any domain.
As we wrap up our deep dive into building effective agents with LLMs, it's evident that this field is rapidly evolving. Anthropic's insights provide a valuable framework for understanding the core concepts, workflows, and considerations involved in designing and deploying these powerful systems. Their emphasis on simplicity, transparency, and carefully crafted agent-computer interfaces serves as a guiding principle for navigating the complexities of agent development.
The potential of autonomous agents to tackle open-ended problems and automate complex processes is truly remarkable. The examples we discussed, from coding agents solving GitHub issues to agents handling customer support interactions, showcase the transformative power of this technology.
It's exciting to consider the possibilities as these agents become more sophisticated and capable. However, as with any powerful technology, it's crucial to approach agent development with a sense of responsibility, ensuring that these systems are aligned with human values and operate safely and ethically.
Anthropic's focus on transparency and explainability is crucial in this regard. By making the agent's reasoning and decision-making processes visible, we can foster trust, understand their limitations, and mitigate potential risks.
This transparency allows us to hold these agents accountable for their actions and ensure they operate in alignment with our expectations and ethical standards. The concept of the agent-computer interface also highlights the importance of designing interactions that are intuitive, efficient, and error-resistant. As we move forward in this era of increasingly capable AI systems, it's essential to prioritize human-centered design principles.
Anthropic's work serves as a reminder that the most successful AI systems are not necessarily the most complex, but rather those thoughtfully designed and carefully aligned with human needs. Their insights provide a valuable roadmap for building effective agents and shaping the future of AI in a way that benefits humanity.
One final thought to consider. As agents become more integrated into our digital lives, we need to think deeply about the implications for human-computer interaction. How will these agents change the way we work, learn, and interact with the world around us? What new possibilities will they unlock, and what challenges will we need to address? These are questions that deserve careful consideration as we continue to explore the frontiers of AI and its potential to reshape our society. Thank you for joining us on this deep dive into the world of building effective agents. We hope you found this exploration informative and thought-provoking.